We will continue in 3.5. Here's the last example that I did in 3.5. This is not multiplied out, but you can see that you have the powers add up to 3. So you know it's the numerator is a third degree, and so is the denominator. So your n and m are both 3, so that's how you get the horizontal asymptote, etc. Now let's go on to number 84 in page 365, or if you don't have that specific in your book, then let's just look at this question, which is basically just graph the rational function x squared, so x squared minus x minus 12 over x minus 2. So first thing you want to do is, and we'll go through the steps, is factor. So you want to factor the numerator. Okay, draw your line, product of two binomials over x minus 2, and so it's x and x. You have a product that's 12, one's positive, one's negative because this is negative, and a sum that is -1. So it has to be 3 and 4. That's pretty, well, it's pretty obvious. So, and this is negative, so it has to be a plus 3. So plus 3 minus 4. Or, of course, you can reverse this order because of the commutative property of multiplication. So you kind of want to mentally double check this. This outside product's -12, and the inside, of course, adds up to be -1. Now you can start writing down all the information. So you have so write down your vertical asymptotes. Write down, are we going to have a horizontal asymptote or oblique asymptote? So vertical asymptote's pretty easy. That's when the denominator's 0, and that's after it's reduced. So this is in reduced form. Nothing can, can't reduce to 1. So our vertical asymptote then has to be x equal to 2. Now let's look at the degrees of the numerator and the denominator. So the numerator has degree 2, denominator degree 1, so it's 1 larger. So since it's 1 larger, we end up with an oblique asymptote. So we will have an oblique asymptote for this case. So in other words, we can write down n is equal to 2, m is equal to 1, and we know that's 1 larger on the numerator. So since it's 1 larger on the numerator, we divide. So divide x minus 2 into the x squared minus x minus 12 using long division. Now you can use synthetic division in this case, but in reality, it's probably best to just do this. So you have x minus 2, because in other words, if this was like a third degree and a second degree, then you can't use synthetic division. So you might as well just use long division when you're doing this, these cases. All right, so x minus 2 divided into that polynomial, which is x squared minus x minus 12. Okay, so what you ask then is what times x is x squared? This one's pretty straightforward, right? So you get x here. Multiply, and you get x squared. Multiply, you get -2x. And then you subtract. Okay, when you subtract, change the signs and add. And you will get x, bring down the 12. And then what times x is x, right? It's just that. which of course is just plus 1. So you get plus 1, and then you multiply and add. So you get just x minus 2, and then we subtract. And you get, when you subtract, you get negative 10. So this is your remainder, your r of x, little r of x. And so you can write, what we know now because of that is that r of x, the rational function, is equal to the quotient, which is x plus 1, plus the remainder, which is negative 10, divided by x minus 2. So here's the idea. What we're talking about for these cases, for the horizontal or oblique, is for large values of x, when x approaches positive and negative infinity. So what we know then, if you look at this r of x, as x approaches plus or minus infinity, what's happening to this number? Okay, and so you have negative 10 divided by, and then this number right here, this is getting really large, like a billion, quadrillion, octillion, that sort of thing. Those are numbers, actual numbers, by the way. Okay, so it's huge. So basically, this whole thing is approaching 0. Okay, so it's disappearing for very large values of x. So what we say, or we can write, is that this is approaching 0. Not r of x, but that little term. So this term itself is approaching 0. And I can write that down. So as x approaches negative and plus or minus infinity, we could say something like negative 10 over x minus 2 is approaching 0. So that's technically what's going on. So you end up, for large values of x, remember this is the end behavior again. What we end up getting is really the graph looks like y equal to x plus 1. So this is what you're graphing then. So this right here, this is your graph for your oblique asymptote. Okay, so we will get to that. We'll graph that in a second. Let's finish things we need to have. We need to do x-intercepts. And we need to do y-intercepts. So x-intercepts, again, you just go back to here. You set the numerator equal to 0 and solve. And you don't really have to show that. You just got to see what they are. So we can see that negative, I almost wrote that wrong, x equal to negative 3. And then you got to know multiplicity. Multiplicity is equal to 1, so it passes through. And we have x equal to 4 with multiplicity equal to 1, so it passes through. Okay, and then y-intercept is, of course, your r of 0. So you evaluate the whole thing, and you really, if it's in this form, then it's easy. You just look at the constant term divided by the constant term, which looks like it'll be 6, but I'll go ahead and show that. So you substitute in, you get 0 squared minus 0 minus 12 divided by 0 minus negative 2. So that's negative 12 over negative 2, which is, of course, 6. Now, the key idea is that 6 is greater than 0. In other words, above the x-axis. That's really what we want to know when we graph this thing. So now let's go ahead and graph this using all the information down here. Okay, so draw on your axes. We'll try to make it somewhat big. and you don't have to, mark off, do the tick marks. You got to get close. Of course, I will do it a little better because I need to make sure my graph x plus 1 looks right. So what we have then is the line, we can graph the oblique asymptote y equal to x plus 1. So it's up 1. Let me show you it to you like this first. So it's up 1 with a slope of 1. So up 1 over 1. So it's basically this slope, right? One slope and shifted up 1. And that's what the graph eventually approaches. Okay, so let's draw on our line. And I meant to do that dotted, actually. Let's try that again. With pencil paper, sometimes I'll draw it and then go back through and erase it. Okay, so we'll just do it like this. I can maybe adjust a little bit so it looks like a 1 slope, which I think I basically got it. Okay, it's pretty close. And then what's our vertical? Our vertical is at 2, so we'll make 2 right about here. So there's our vertical. And now I'll go ahead and put in the arrows and label. So you want to label this. This is your x equal to 2, and this is your y equal to x plus 1. Okay, and I put this down too. Your slope is 1 over 1, and your y-intercept is 0, 1. So this is going through 1 right there. Okay. Now we can start with the graph. We can do the intercepts, right? So we can label the x and y intercepts. So this point right here, you would need to know because it's basically, if this is 1, 1, it's down 1 over 1, right? That's your slope. So this point right here, I was going to do green for the graph. So this point right here is your negative 1. And of course that's your positive 2 there. So then your graph goes through negative 3, so it's out here. And your y-intercept is at 6, which would have to be somewhere up here. And because of the graph, the way it's done, I'm going to move this over a little bit. Let's do it like that, I guess, close enough, because I didn't have to make that approach it. Okay, so what's the graph going to do there? And then we also have, 4? So 4, we'll just say, is out here. All right, so the graph, again, must approach the asymptote, right? It can't be both, or it's not a function. So it has to be kind of, it has to eventually go here. Now, it can cross, okay? And we can find that out, but you don't really need to unless I ask. So, well, it was really, and then what about multiplicity? So does it pass through these roots or bounce off any of those? I'll go ahead and label this. This is negative 3, and this is positive 4. So yeah, multiplicity is 1, so it has to pass through both of those. So take a second and figure out what the graph is. So can the graph do something like this? Can it do that? Of course it can't do that. Otherwise you'd have an intercept. So the only intercept is here. So it pretty much, can it be up here and turn and come back down? No, because there'd be another intercept. So there's only one way it can go through here. It can only pretty much do this and then approach the asymptotes. And it's nice and smooth. It doesn't take any, strong bends or anything. Looks basically like that. Similarly, over here, can you have that? That's a possibility, but can it be that? Of course not, because there's an intercept here. It has to hit here. So can it be like this? No, because it has to approach the asymptote. So it could do something like this, but then you'd have another intercept. Okay, so it cannot do this. So there's only one way this can pass through all of those points. It has to be this. And that's it. That's how you graph it. You have to reason through it. You don't just plot a bunch of points to see what's happening. You want to reason through why it does what it does. Okay, next example, let's look at this one. Okay, this is, let's see, this is next example. This is number 83, not that it matters really, but graph f of x equal to x squared plus 7x plus 10 divided by x plus 3. Okay, so this is usually a you try it one. Okay, so try it, go through all the steps, pause the video, and then see what you get. Okay, so the first thing you do is factor, right? So you factor. Well, you can look at a couple things. I mean, really, you can look at a couple things. You can look at the degrees. Okay, so there's one larger again, so this will be an oblique case again. Okay, I'll go through this somewhat quicker this time because it's very similar actually to above. So yeah, you graph it or you factor it. Okay, so product of two binomials, x plus 5, x plus 2, double check, looks good, over x plus 3. Okay, label your vertical asymptotes. It's just x minus 3. This is an oblique asymptote because it's one larger, so you do your long division. So it's x squared plus 7x plus 10. So it's going to be x, you get x squared plus 3. Then you subtract. So you get 4x plus 10 and then a plus 4. Multiply and you get 4x plus 12. Subtract and you get a negative 2. So this remainder doesn't matter. So this is all you're looking for. So you pretty much can stop there and you say x equal to x plus 4 is the oblique asymptote. X-intercepts, just continue, are plus, are x equal to negative 5, multiplicity 1, and I'll put it down here, x equal to negative 2, multiplicity 1. This said that negative 2 has nothing to do with it. This is your remainder. Okay, remainder doesn't matter, right? I mean, it'll disappear is what's kind of the point. Okay. Oh no, one more. So y-intercept is f of 0, which is 10/3. All that really matters is that's positive above the axis, and it helps us determine what the graph has to look like. Okay, we're ready to graph. Oops, I was trying to make that straight. There we go. Try that again. Okay, there we go. All right, so now we have the graph. This is a slope of, where's the slope? Slope of 1, but up 4. So really though, it's really the same look of the graph. Kind of like that. It's at 4 units. Let's make that 4 units right there. And then now we're at what? What's the other vertical? Negative 3. So you're negative 3. And you kind of want to do this pretty close. I'll show you what I mean. So you need to know right now, actually, this point here. So what's that point? So you were up at, zoom in a little bit here. Okay, so you were up, this is 4, and then you're basically, this has to be negative 4 because you're down 4 over 4. or down 1 over 1 like that. So it has to be a 1-to-1, so 4 over 4. So this is -4, and this is 4. That means something because of your next vertical asymptote is at -3. So your -3 has to be right about, maybe here. So that's what it's going to look like, something like that. So it's on the inside of that. So you want to be able to show that. So you do have to get somewhat accurate. Okay, so let's label these lines. This is x equal to -3. And this is y equal to x plus 4. Label my axes. That's what I should do. All right. What else do we got? We got our intercepts. The intercept's at -5, so it's right here. And -2, right, is right about here. 10/3. 10/3 is less than 4. It's right about here. So there's your 10/3. And you just get a decimal to figure that out. Okay, you want to know that it's not above that, because otherwise your graph would do something like that, and it really doesn't. Okay, so you want to, just divide it. You'll get 3 1/3, right? So it's up there like that. And then we have, let's label these. This is -2, and this is -5. All right, so think about what the graph has to look like, or you actually, I guess technically you should have already tried it. Okay, so passes through. So this is very similar. So it has to just do that. Can't be down here only, right? Because it has to pass through. Same thing here. It can't go up because if it did, it would come down cross. Well, now it has to turn and go back up. So it can't do that. It has to cross again. So there's only one way it can go through these values, and that's it. Do not plot more points. Okay, like that, and like that. Okay. Next one. That last one will do. And if you can do all these or ones similar, you're in good shape. This is what the questions will be like on the exam. Next example. Graph f of x equal to 4x over x squared minus 2x minus 3. All right. First thing you do is what? Factor, right? So you factor it. So what's let me clean that up a little bit. Degree of the numerator compared to the degree of the denominator. You're thinking that right now. Okay, so first we factor. This is x minus 3x plus 1. Difference is -2. Okay, that looks right. Okay, so I like to do vertical asymptotes always first. They're kind of like the easiest ones. You just look at the denominator. When is that 0? It's already in factored form. So it has to be 3 and -1 are your vertical asymptotes. Okay, horizontal asymptote or oblique. Well, you have the degree of the numerator is 1. Degree of the denominator is 2. So this means what? It means y equals 0, or the x-axis is the horizontal asymptote. Okay, intercepts. So x-intercept, or one or more. Y-intercept. So this one just has 1 at 0. Multiplicity is 1. And then when you evaluate, well, you'll get 0 again. So your y-intercept is, again, 0, 0, 0. So there's only one intercept that passes through those. Okay, so now let's go ahead and graph this thing. Okay, so draw on your graph and your vertical asymptotes. So vertical asymptotes are at 3 and -1. So here's 3 and -1. Okay. And notice I'm not really counting, I'm just kind of getting close. It doesn't, you want to just have it look pretty, pretty nice. So here's -1, here's 3. Okay, now here's the thing. You know that it passes through. Let's do this one in blue. You know it passes through 0, 0. But the thing about this one is, and then we have the horizontal is the x-axis. So now it basically has to either be this or this, and then the middle, it's got to be this one, or it's got to be this one. It can't bounce and go back up, or it can't cross and go back down, or you'd have another intercept. So this is the case where you have to choose points to figure out whether it's above or below the x-axis. This is the only case you have to do this. And in this situation, you have to do it 1, 2, 3 times to figure that out. So we have to evaluate. So this is where you need to choose test points. So you need to choose test points to determine if the graph is above or below the x-axis. Okay, so that's what we want to do. Okay, so that's our key thing we got to do now. Okay. So I like to choose easy test points. So I'm going to choose in between. So I'll choose actually I don't want to use that color. I want to choose, we'll do test points in that color. Okay, so we'll choose 1 to see if it's above or below. You can choose -2, but I'm going to choose -10. So that it'll reveal itself sooner. You could choose 3, or you should choose 4, but I'm going to choose +10 for the same rationale. Then you know kind of quickly what happens, whether it's positive or negative. And then you evaluate. You say f of 1. And if you do that, where's my function? You get 4 over 1 minus 2 minus 3, which is negative. It's actually easier just to plug it into here because you're just multiplying. So it's -3 times 2. So that's -2/3. So it's less than 0. Actually, let me move this over here. I don't want to do it all there. We'll just put it down here. So these are your test points you're doing. So the key here, the most important thing on this is that this is less than 0. That means it must be down here somewhere. So the graph cannot do this. It must then or therefore go like that. And then you have to, you may go ahead and graph it. What color am I doing? Oh, I'm doing blue. Okay, so it has to go like this and then down. And you don't even have to plot that point, but that's what it has to look like. Okay, so do the same thing for the other points at -10 and 10. So if you do, you don't have to actually evaluate the whole thing. You just plug it in and see what happens. So if you do -10, you get -40. You get -40 over. Where's where to go? And this is a negative, and then another negative. So that's less than 0. It's negative. So all I'm doing is looking at these factors here. I'm not even evaluating it. I put in a negative 10 here. This product's negative. I put in a negative 10 here. This product's negative. Put in a negative 10 here. The numerator is negative. So the product or quotient of 3 negatives is negative. It's an odd number of negatives, so it's a negative number. So you're not actually having to evaluate. That's all you're doing. Okay, next one. Let's do f of 10. Same rationale. Right, so and I'll show this one. It's 4 times 10. So this is what you're doing. You're plugging it in. 10 minus 3. And then 10 plus 1. Everything's positive, right? You don't have to evaluate it. It's just, you know, it's positive. Okay, so once you know that, then you know it has to be above the x-axis. So again, are there any intercepts on the outsides? There's none. So it has to just remain above it and here down below it. It can't cross. It can't be above because it has to get to that negative value. So there's your graph. Okay, so your graph has to be above the x or below the x-axis on the left-hand side, like this. And it has to be above the x-axis on the right-hand side, like this, or positive side. So that's where you have to choose points carefully, not just randomly plug in points. That is missing the concept of these. Okay, so there's a number of other things to practice to get good at these. So continue doing that, and then we'll go on to 3.6.